All right, now we're going to look at transformations of trig functions. Okay, so I've got here, we're going to transform from y equals sine or cosine of x. A lot of the properties are the same, so that's not sine divided by cosine, that's sine of x or cosine of x. So in this case, you've got a out in front. The absolute value of that is the amplitude. So a can be a negative number, which means a vertical flip, but its amplitude is always positive. So you take the absolute value. Sine or cos, k times x minus c. Now this needs to be factored on the inside, otherwise you don't get the transformations proper. And then plus d. Okay, so with trig functions, we've got transformation properties, but we also got some special names for some of it. So k represents the number of cycles. So the absolute value of k represents the number of cycles between 0 and 2 pi. Okay? So if that was a 2 in there, you'd have 2 full cycles. So sine of 2 theta, you have 2 cycles between 0 and 2 pi. The horizontal stretch factor is 1 over the absolute value of k. Okay, and that's what we get from transformations. 1 over this is the horizontal stretch factor. C is the horizontal translation. And D, well, that is the vertical translation. Okay, so with the horizontal stretch factor, we've got a number of things. We've got this number is the number of cycles between 0 and 2 pi. 1 over k is the horizontal stretch factor. And the period, which is the length it takes for one cycle, is the formula 2 pi divided by the absolute value of k. All right, and if you want to find k, well, it's 2 pi over t. So you can do it either way. And then c, instead of being called the horizontal translation, in trig we call it the phase shift. Okay, so one phase is like one cycle. And then d is a vertical translation, but we say y equal to d is the equation of the axis. It's not the axis of symmetry, because there's not symmetry in that, but it's the axis that cuts the periodic function in half. Okay, so it's right between the maximum and the minimum. So, for example, if you wanted to graph y equals, or if f of x equals negative 2 cos of x plus 2, this only has vertical transformations in it. We're going to graph it between 0 and 2 pi. So if there's vertical transformations, what are they? Well, you got the first one, which we go by stretch factors first. It's going to be stretched by a factor of 2 vertically and flipped vertically. And then it's going to be translated up 2. Now, if we just look at what we've got up here, this 2 at the end is the d. The 2, so y equals 2, is the equation of the axis. So that's going to cut it right in the middle. Cosine normally starts at the top. Because it's been vertically flipped, it's going to start at the bottom. And then it's going to have an amplitude of 2. So the absolute value of negative 2 is 2, so it has an amplitude of 2, so it's going to go from 0 to 4, same distance above and below the axis. So we can draw this in between 0 and 2 pi like that. We shouldn't need much to get this graph. Okay. Now, the next one. If I wanted to graph f of x equal to sine of 4 pi, or 4x minus pi between 0 and 2 pi, well, this is not the proper format for trying to get the transformations from it. So what do we have to do? Well, we need to factor out the 4. And you end up with this. Now you can get the period from this. The period is 2 pi over 4, which is pi over 2. You can also tell the number of cycles in this graph between 0 and 2 pi. So you can draw 4 cycles between 0 and 2 pi, so 4 periods. And then the pi over 4 is a horizontal shift. Okay, it's a horizontal translation, or the phase shift. So it's going to be moving to the right, pi over 4, the opposite of the negative here, opposite of this sign. Okay. So what I do to graph this, just got horizontal transformations. I'm going to ignore the pi over 4, and I'm just going to graph 4 cycles between 0 and 2 pi. Okay, so if I do that, I'm going to get this graph here. So ignore these numbers at the bottom here for now. So I graphed in pencil the y-axis, and then I marked off 12 centimeters here, which is nice and convenient to get the proper markers in there in a quarter period. Okay, so I've got that. And then I plot 4 cycles. So I'm going to have dots at marks at every pi over 8 across here. Now I did this in pencil at first, and I left it in pencil until I sorted it out. So if I have to push this graph now by a phase shift of pi over 4 to the right, instead I've got this y-axis in pencil. I can erase this and move the axis pi over 4 to the left, and then put in my horizontal markings. Okay, so my horizontal scale. So instead of moving the function to the right pi over 4, I just move the y-axis to the left, and now I can erase the pencil y-axis, and I can erase this part here, and I've got the graph between 0 and 2 pi.